Hi, scholars. This week we're going to explore the Pythagorean theorem through sports. Particularly, we'll be using football. Now, you may be already familiar with this theorem, but we're going to take this week to review it since you will need it later in the unit. So here is the Pythagorean theorem. A squared plus b squared equals c squared. Now, it's an equation, and the definition of the Pythagorean theorem says that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides, which out of context, that doesn't really make sense. So let's look at it and think of it like this. So say we have a right triangle, and this is my right triangle. It's denoted by my little square in the corner. And I'll say that this side is 3, this side is 4, and this side is 5. Now, remember, we're saying that it says the square of the hypotenuse, that's going to be C, is equal to the sum of the squares of the other two sides, A and B. So what it's saying is if I make squares off of these sides, right, a square, then the area of those squares will equal the area of the big square. Let's check it out. 3 times 3, remember, area is length times width. So 3 times 3 is 9. So the area of, we'll call this A, is 9. And the area of this side we'll call B. 4 times 4 is 16. Well, 16 plus 9 is 25. And according to this theorem, that should be the area of the side C, the long side. This is the hypotenuse. So 5 times 5 is 25. So when I add the squares of sides A and B, I get the square of C. Okay? Now, just to remind you, when we do have a right triangle and we're using the Pythagorean theorem, just some things we want to know. We have our right angle denoted by the box. This side across from the right triangle is called the hypotenuse. That's called the hypotenuse, and it is C, denoted by C. And then A and B are over here. Now, it doesn't really matter where you put them. You can put them on either side. Just make sure that C is always the longest side. The hypotenuse is the longest side of a right triangle. Right triangle. And remember that a right triangle is a triangle with a 90-degree angle. Okay? So now let's take a look at an example. So how do we actually use the Pythagorean theorem to solve problems? Well, sometimes we need to figure out the distance of something or the height or the length, so we can actually use the Pythagorean theorem. Here we are on a football field, okay? And this is going to be my quarterback, the blue one, and he is going to throw to the receiver over here, the yellow circle. So let's say at the beginning of the play, I'll do some labeling here. We'll say at the beginning of the play, the receiver ran down the field and he ran about 24 yards, okay? He ran 24 yards. And the quarterback, we'll say, is about 7 yards from this location, okay? So how far then does my quarterback need to throw the ball? Okay, we don't know. What is it? Well, this actually is going to make a right triangle, okay? And we can use the Pythagorean theorem here. So let's remember that the Pythagorean theorem says that a squared plus b squared equals c squared. Remember, the hypotenuse is the long side, that's C, and then this will be A, and this will be B. So that means I'm going to take the 7, that's side A, squared, plus 24, which is my B side, equals C squared. Okay, now this is where I'm definitely going to need a calculator. 7 squared, I know, 7 times 7 is 49, plus 24 squared, and I'm actually going to pull up the Desmos scientific calculator because I need to square root. So when I take 24 squared, I get the number 576. Wow, that is a large number. 576 equals c squared. Okay, so now I've just done a little bit of multiplying, squaring. I have to add these together. So if I add 576 plus 49, I get the number 625. Okay, 625 equals c squared. Now, this seems like, oh, am I done? Well, not yet, because I still have this square here, right? So what I have to do is take the square root of both sides, and I will say the square root of 625, I can put it in my calculator, and that number is 25. And the square root of c squared is just c. Remember, anything that's squared like this, when we take the square root, it's just the original. So now I know that my quarterback threw the ball 25 yards. Okay, so that is one application of the theorem. Now, in this example, we're going to determine how far the receiver has to run to catch the ball. And I'm going to change my color to red. I think it's going to be a little easier to see. Actually, I think white will probably be the easiest. Okay, so to begin, let's say that these guys, from here to here, they're about 8 yards apart. Okay, so between the quarterback and the receiver, they're 8 yards apart. And at the beginning of the play, the receiver runs straight down the field here. Okay? And then the quarterback is going to throw the ball 17 yards. All right. So this very nicely makes our beautiful right triangle. And I can ask you, well, how many yards did the receiver run? Well, here's the thing. We know that the side across from the hypotenuse is called C. So we know that C is going to be 17. We can call this side A down here. Remember, it doesn't matter A or B. And so we're solving for B. How many yards did he run? And let me grab another color that you can see. So we're going to use our Pythagorean theorem to figure out how many yards he ran. So A squared plus B squared equals C squared. Okay, we have a right triangle. We can use this. Well, A we know is 8, so we'll plug that in. 8 squared plus, we don't know what B squared is, equals C is 17. 17 squared. All right, again, I'm going to need my calculator. I know that 8 squared is 64 plus B squared, nothing changes. And then here I go, I'm going to plug into Desmos here. Still getting used to this calculator. So 17 squared, here's the account. Okay, 289. 289. All right, well, now we have to practice solving our equation. We can't just take the square root of both sides because this b squared is attached to the 64. So I'm going to subtract 64 on both sides, and I'm left with b squared equals, all right, let's see if I can reason this out. 9 minus 4 is 5 to 225. Okay, that sounds like it's going to work out for us. Let's find out. So the last step, now that I have my variable on one side and my number on the other, I will square root these. When I square root something that's squared, it takes away the squared and we're just left with the variable. And now over here on Desmos, on my other screen I'm working on, I'm going to take the square root of 225 and I get an awesome number, 15. Okay, 15. So for my original question, how many yards did he run? Well, he ran 15 yards. Okay, so there is another application. All right, for this last example, we're going to get a little bit tricky. So for this play, after the ball has been hiked, the quarterback wants to throw to the receiver, and the receivers run all the way here to the 40-yard line. But let's say our quarterback is blocked, okay? So he can't throw. So he comes this way, all right? He comes a little bit to the side. Now he's going to throw to our receiver, and we can see that the receiver went from the 20 to the 40. We can actually count. It goes by 5, so, or you can think tens, but 5, 10, 15, 20, 25, 30, 35, 40. So we know that the receiver ran 40 yards. Okay, and I'll tell you then that the quarterback, he throws 41 yards. Okay, so he throws this 41 yards to the receiver. So now we have to find, let's call this A, right? We don't know. We know this is my hypotenuse, right? It's across from the right angle. And this will be B, that's fine. Now we have to solve for A. What could A be? Well, the great thing is we have this handy dandy Pythagorean theorem. So let's try it out. So we're going to say a squared plus b squared equals c squared. See, the lovely thing is anytime you find a right triangle, you can use this. If you ever need to find a distance or a height or something. So we don't know what a squared is. We're trying to figure out, well, how many yards did he move before he threw the ball? B squared is going to be 40 squared. That's going to be a big old number. And c squared will be 41 squared. Okay, so all we're doing is plugging in the numbers for the variables. All right, so here we go. I'm going to get my trusty calculator. So a squared plus 40 times 40, I think that's 1600, right? Let's double check because I don't trust my math. I don't trust my, yeah, 1600. I don't trust my arithmetic, I'll tell you that much. And then 41 squared, anyone got a guess? 41 squared is 1681. All right, so I have just done the calculations, right? I plugged my numbers in, I did the calculations. Now I have to do some subtraction, right? I can't have this thing connected by addition here. So I'm going to subtract 1600 from both sides. Get used to doing this, okay? I'm left with a squared, because remember, this cancels out. 1600 minus 1600 is 0. That's the whole thing. We're trying to get it 0. Now this is going to just be 81. Okay. All right, and then we'll take the square root. Something feels funny about this. The square root of a squared is just a, and square root of 81 is 9. So this was actually, no, this is right. This is a Pythagorean triple. We can talk about those. You can ask me about those. I don't know if we'll have that much time to go over them. So we know that 9 yards, that our quarterback, he moved 9 yards so he could throw the ball uninterrupted. So there you go. Pythagorean theorem does have real applications in sports and things like construction. So we'll try this out this week and see how it goes.